Module 7, Objective 3, be able to list receptors classified by the type of stimulus that excites them. Proprioception is a medical term that describes the ability to sense the orientation of the body within the environment. Proprioception is a constant feedback loop within our nervous system, telling your brain what position you're in and what forces are acting upon your body at any given point in time. This sensation is purely somatic sensation, and we lack proprioceptors within our visceral organs. So you can't tell where your spleen, appendix, or pancreas is in terms of location. General sensory receptors are divided into 4 types based on the nature of the stimulus that excites them. We have nociceptors, thermoreceptors, mechanoreceptors, and chemoreceptors. Nociceptors are pain receptors. These are free nerve endings with relatively large receptive fields, and they're very commonly found in the superficial portions of our skin, in and around our joints and the periostea of our bones, as well as within the walls of blood vessels. And they're sensitive to temperature, changes in temperature, mechanical damage, or dissolved chemicals. Thermoceptors record temperature, and they're conducted along the same pathways that carry pain. So sometimes extreme temperatures can feel very painful because the brain is interpreting these signals along the same pathway. Thermoceptors are free nerve endings located in the dermis of the integumentary system, skeletal muscles, liver, and hypothalamus. Mechanoreceptors are sensitive to stimuli that distort the plasma membranes of the cells due to the presence of mechanically gated ion channels, whose gates open or close when the membrane is distorted, generating graded potentials which, if strong enough to reach threshold, are then converted into action potentials. And mechanoreceptors operate in response to stretching, compression, twisting, or anything that really distorts that plasma membrane. There are 3 classes of mechanoreceptors. Tactile receptors provide sensations of touch, pressure, or vibration. Barrioreceptors detect pressure. If you know the term barometer, barometer measures atmospheric pressures. So barrioreceptors detect pressure changes in the body. And mainly this is found within blood vessels, but you also have it within our digestive, respiratory, as well as urinary tracts. And then proprioceptors. Proprioception, again, monitoring the position of joints and skeletal muscles. I often think of these proprioceptors in terms of a carpenter's level. If you've ever tried to level something, you have a little tube with a bubble, a gas bubble, and use that to sort of level whatever it is you're working on. So when I think of proprioceptors, I think of that carpenter's level, monitoring positions of joints and skeletal muscles. Here are the barrioreceptors in the body. We have some very specific barrioreceptors. The carotid sinus and the aorta have these pressure receptors, and they're going to provide information on blood pressure. We have barrioreceptors within the lungs. As the lung expands through respiratory rhythmicity centers, they're going to measure the pressure within those structures. Within the digestive tract, we're looking at the volume within our digestive tract, and we find these barrioreceptors also trigger not only the reflexive movement of materials down, but in the colon, they're going to trigger the defecation reflex. As the colon fills it's going to trigger this defecation reflex, which is going to initiate defecation. And then lastly, baroreceptors are in the urinary bladder, the wall of the urinary bladder. And again, as the volume of urine increases within this structure, these baroreceptors help trigger the urination reflex. Chemoreceptors respond to both water and lipid-soluble substances that just happen to be dissolved within our body fluids. They tend to exhibit a fair amount of peripheral adaptation, and they're going to monitor things like pH, carbon dioxide levels, as well as oxygen levels in the arterial blood. So the carotid bodies, these are chemoreceptors near the internal carotid arteries. The aortic bodies, for example, are chemoreceptors within the aortic arch. And again, they're going to detect the presence of chemicals, namely pH, carbon dioxide, and oxygen. Here we're going to see the placements of some of these chemoreceptors in and around the medulla oblongata. They're going to be very sensitive to changes in pH and carbon dioxide levels in cerebral spinal fluid. And they're going to trigger reflexive adjustments in the depth and the rate of our respiratory. Within the carotid bodies and the aortic bodies, these are going to be sensitive to pH, carbon dioxide, and oxygen levels in the blood. And they're going to trigger reflexive adjustments both in our respiratory and our cardiovascular activity.